Hi, this is Paul again, and I've got another new video to show you. And I'm calling this Quad Step 288 Celtic Ring Geometry. In the last couple of years, I've put a lot of research into a system I call Quad Step 288. In front, I'm showing a group of 5 balls. Now each of these balls are linked in a hierarchy, 5 to 4 to 3 to 1. Now what I'm going to do is make a copy of that group of 5 and then link that copy on the red ball. Now I'm going to make a third copy of that group and link it together so that 12 balls are in a hierarchy. Okay, I'm using a version 10 of 3ds Max. Now if I select this group of 12 balls in a hierarchy and give it a 24 degrees turn, look what I've got. The string of 12 is closing around a triangle. Now 12 times the angle of 24 comes to 288, not 360 degrees. Now the reason for this is because we are using groups of 4 and the 5th ball isn't accounted for. Now this 288 system has a great advantage because the groups of 4 can be linked together in a long hierarchy. Okay, I just shown that a group of 12 can give a triangle. But my next step, instead of using 12, I'm using 16. Now I linked a load of copies of this 16 string together, and this is what the results are. Now by dividing 288 by 16, it comes to 18 degrees. And because I made a load of copies of that 16 ball string, that is why she's spinning around until it comes down to the 18 degrees. Okay, I'm going to make a copy of that anim, and then I'm going to do the same, and then I'm going to stop it at a pentagon. Okay, she spins right down to a pentagon, no problem. And then I'm going to do exactly the same, and I'm going to stop it on a hexagon. Let's take a look. Okay, the next one's going to be a 7-sided. So that's going to be called a heptagon. I draw the polygon between the centers of the red balls, but you cannot see it until I finish the anim. Okay, now you can see the 7-sided polygon as we start the new anim. Okay, the next anim is going to give us the 8-sided, the octagon. I think anybody can see that we produce in a beautiful order. Okay, the next one we're going to do is a 9-sided. Let's take a look. And I believe they call this 9-sided the nanogon. Let's move on a bit with the anim and we can see it. Okay, the next polygon coming is the 10-fold, the 10-sided polygon, which is associated, I think, with BDNA. Okay, the next one we're going to do is going to be 11-sided. And I believe the Greek word for this is a hendecagon. Okay, let's bring the next one in. And this is going to be a 12-sided. And this is called the dodecagon. Okay, the next one is going to be, unlucky for some, 13. Now I checked for a name of this on the web and they call it a 13-gon. Okay, I guess this is getting a bit boring for the people that want chaos and disorder. But I've only got a couple left. This one's going to be the 14-sided. And I think the 14-sided is going to be a dashagon also. So this is 14-gon. I guess the chaos theory pushers will be wishing that I be gone also. My next ring is going to be a 60-ball ring, and this is the same as Stonehenge. Well, at least I say so, but the English academic said it was unsuitable for publishing. I think I was treated unfairly, but I guess the academics don't want to stop the chaos theory conventions. Anyways, let's get back to this 15-sided polygon. And they say this is called a pentadecagon. There is a reason I called this Celtic ring geometry, because stone rings are found in many parts of the UK and Western Europe. In the history books, the Celts were described as being uncivilized, but maybe it was the other way around. I believe the Celts were very advanced in the mathematics of stone ring geometry. It was found that rings were found inside the stones of Stonehenge. They have also found rings of larger diameter around the stones of Stonehenge also. Anyway, that's enough rings for today. So this is Paul saying thank you very much for watching my video.